In our last video, we found the first derivative of the function y equals f of x, which is equal to sine of x all raised to sine of x power. And our purpose of taking the derivative is to help us finding all the informations that we need so that we can analyze the function and answer the problems such as where the domain, the range, the relative maximum, relative minimum, as well as the absolute maximum and absolute minimum of the function. And again, if you did not watch the first part, which is the last video, please go to watch it first so that you can see how we get the first derivative of the function. And now we're going to move on and trying to analyze the function without using the graph. So what can we do? Again, as always, it will be easiest to do if we can try to make a table so that we will actually see how the function goes when we try to pick some specific points. Now to do so, we need to answer a couple questions first. After we take the first derivative, where can we find the relative maximum and relative minimum? In other words, what should we do to find out the relative extrema? We know that the existence of relative extrema locates at two wheres. One, when the first derivative of that specific x value is going to be 0. Second, if that x is considered as an endpoint of an interval, no matter if it is it has to be a closed interval. And again, why it cannot be in an open interval? Because the endpoint of an interval must be included inside. And if we have an open interval, we will never be able to choose an endpoint at the end that is not closed. Because again, if we try to pick a point that is very close to that end, we can always find another value or another point that is even closer to what's so-called the end of the open interval. So if we want to check it, of course, we need to set this equal to 0. So that now we're going to see what x values can satisfy this equation here. So, of course, we need to see how to make the product equal to 0. And since we're actually doing with real numbers, we know that the product is equal to 0 if and only if at least one of the factors is 0. So, as always, we now have 3 factors. We'll set it into 3 cases. So, case 1, the first factor, sine of x raised to the sine of x power is equal to 0. When would this happen? Well, first, do we agree that sine of x is just another function? Let's call it using a different variable. Let's say u. Okay, which is similar to a u sub. Then in this case, if we let u be sine of x, the left hand side is just equivalent to say u to the u power. But we actually did this already in the very first part of this short series. We have analyzed the function x to the x power, and here we call it a dummy variable because we can use any letters or any variables to represent this kind of function. But we know that this function will never equal to 0 on the real line. So what does that mean? It means that this part will never satisfy. In fact, we have already analyzed that this function is always positive or greater than 0 if we consider with real variable. So if we substitute back in here, this part, in order to be a continuous function, this will have to be equal to have to be greater than 0 as always. Or in other words, this part will always be positive. Good. Next, we have to look at the second part, cosine of x. And we are going to assume that cosine of x is equal to 0. When would that happen? Well, this is one of the special values. And hope you all remember, this is true if and only if x is equal to pi over 2 or 90 degrees, and then plus multiple copies of pi. Okay? In other words, for n is any integers. Good. So we now have one situation that might satisfy. Next, we saw the third term, which is 1 plus ln of sine of x, which is equal to 0. Again, to solve it, we first move the 1 to the other side and change it to -1. Then we're going to remove the ln, the natural log, by raising it with base e. So we're going to get e and e here. What do we get? We get sine of x is equal to e to the negative first power, which is 1 over e. Excellent. And does it work? Yes, because 1 over e is actually a number between 0 and 1. So this actually has some specific values if we try to take the inverse sine function. Meaning if we're going to remove the sine and make it into arc sine, or some people write a sine to the negative first, but that is not an exponent, and that is the inverse notation. We'll actually get something like this. We'll get arc sine or sine inverse of 1 over e. And of course, since sine is a periodic function, we are going to add some other things in order to get other values, such as here, by definition, arc sine, if arc sine is between negative pi over 2 to positive pi over 2, and if the value inside of the arc sine function is positive, we know that it'll give us something between 0 to pi over 2. But if we consider the sine function itself and look at the graph, there is another value that's satisfied in quadrant number 2 if we use the unit circle. Or in other words, there must be another value between pi over 2 to pi that also satisfies this condition here. How do we get that? Well, we can just use the trigonometric properties. That will actually give us the other option, which is pi minus this angle here, the sine inverse of 1 over e. And of course, after that, we have to add 2 pi n, because sine is a periodic function, so it has a period of 2 pi. So if we add 2 pi, we will actually get technically the same angle, and we will actually yield to the same results after we plug it into the sine function. So again, we have two options here, and we still have n to be some integers. Good. So now we claim that there are 3 types of answers that might satisfy this condition here, where the first derivative is actually equal to 0. So I'm going to erase the board and then put the answer up here, and we're going to actually start moving on to look at the domain and the range of the graph. Okay, So far we actually get 3 types of answer. Well, in fact, it should be considered as 4 different types, because we're now thinking it as the 4 different answers inside of 1 period, which is 2 pi for sine function. So we actually get 4 different answers, but do they all satisfy? And what would the domain of the original function, sine of x raised to the sine of x power, is? Because again, the domain of the original function will actually determine whether there's any answers that are actually lying outside of the domain or considered as extraneous solutions. So how do we do it? First, we have to go back to our original function, y or f of x. So in the last video, we actually didn't take the derivative of the original function, sine of x raised to the sine of x, right away. And in fact, the way that we usually do these kinds of derivatives is we need to rewrite the base from some function into some constant. So in this case, we actually rewrite the sine of x base here as so in this case, we'll actually rewrite the base sine of x. Let me use a red pen. Into sine, which is now being part of the exponents. And to do so, we have to use one of the properties, which is e. Let me write it this way: base e raised to the ln of whatever the original base is. So it will look like this. And again, if we put the two exponents together, we now end up with e to the sine of x times ln of sine of x power. Why do we have to do this? Because we now need to consider of the continuity of this function here to determine where the domain of the function is, because we want to use continuity to help us find out how the graph will look like, and also try to analyze the function. And to make it easy, we don't want to think of any big discontinuity, such as isolate points or too many jumps back and forth and all the stuff. And that's also a reason why when we consider the function x to the x power, which is actually the basic form of what we have here, we don't consider the negative side, even though we can have some possible negative values, such as the negative integers, that will actually give us some outputs. So another way to think of it is, because we want not only the continuity, but we also want to see how to make the graph by using the first derivative. We also need to have the function being differentiable, meaning that it can be differentiated, or you can take the first derivative and the values will exist in what we have chose. What we have chosen. So what do? When we look at here, we actually can see that in the exponent is made out of the product. We know that the range of sine function is between 1 and -1. So far so good. This has no problem for all x real numbers. So the sine of x part is not really the problem. How about here? It actually does. Why? Because we know that in order to have some output or some values for the logarithmic functions or even a natural log function here, we have to have the input inside the parentheses being positive. It cannot be equal to 0. It cannot even be negative, at least when we are concerned with within the real numbers only. So in this case, we actually have a restriction for the sine function. Since it needs to be positive, now we claim that sine of x has to be between 0 to positive 1, where 0 is excluded and 1 is actually included. But in this case, not all the x values can satisfy anymore. In fact, some x values have to be removed. And since sine is a periodic function, we can consider everything inside of one period. Let's say we pick from 0 to 2 pi. We just need to consider what values will be satisfied. And then after that, we just need to add multiple copies of 2 pi's to actually generate all the all the intervals that we want, and it will give us the actual domain of it. So let's see, if we try to solve this inequality, we need to take the inverse of the sine function, of course, meaning that we need to use the arcsine function or sine inverse. So if we do that, we're now going to get the following value. When when sine of x is greater than 0, x must be between 0 to pi. Again, we're now going to consider the sine function itself, and we're only looking the let me use a different value, g of x here. We're only looking for one period from 0 to 2 pi. And the sine function looks like this. Again, we have maximum here, minimum here. And when do they occur? We have the maximum at pi over 2 and minimum occurring at 3 pi over 2. So we can also use this graph to quickly help us to find out the answer. So in order to be between 0 and positive 1, and of course we include the endpoint 1 here, or the value positive 1. From the graph, we can only take this part here. So in this case, we have x has to be between 0 and pi. And again, we have to exclude the two endpoints, because when x is equal to 0 or x equals to pi, sine of x is going to give us 0, which is the value that we have to be excluded. So we cannot take the two endpoints in this case. And again, is there anywhere else inside of this period that actually satisfies this condition? No more, because again, everything after pi will be either negative, or when we hit back to 2 pi, it will give us 0. So this is the only interval inside of one period that actually satisfies the condition that sine of x has to be positive, so that it will satisfy the condition up here, which says the exponent on the red side here is some real numbers. Good. So now we have a restriction on our domain, which is down here. Let's see if there is any more restriction that we need to consider of. Since we have already analyzed the original function, the second thing that we need to analyze right now would then be the first derivative that we have already did. So let's see. Here we have no extra conditions other than sine of x has to be greater than 0, based on the fact that the function x to x power or u to u power requires u to be positive. But this will be the same as the condition that we just had. So this is still satisfied. Now cosine could be is a continuous function on the whole real line, so there is no condition for x just for cosine part. For here, again, the only condition that we need to consider of is anything inside of the natural log. But this is actually the same as the condition that we just considered of. So it means that the interval from 0 to pi will also satisfy the condition of the factor inside of the parentheses. Therefore, now we actually can answer our first question. Our first question, which is the domain of this function, y equals f of x, which is equal to sine of x all raised to the sine of x power, would be any values of x plus, I'll write it in some notation like this, x plus 2 pi n, such that x has to be between 0 to pi, and for any integers n. So what does this mean? It means that when we consider the domain of this function, we have infinitely many intervals, and they're all open intervals, of course, where each interval will have a length pi, because it will be from 0 to pi, or it will actually get a shift by adding or subtracting multiples of 2 pi, meaning we can just add 2 pi or subtract 2 pi on both ends, and then give us the a new open interval that is also part of our domain. For example, if we add 2 pi on both ends, we now actually get 2 pi is less than x less than 3 pi, and this open interval is actually a shift of the initial interval that we chose, that actually will still satisfy the being part of the domain of the original function. Good. So for the rest of the problems, I'll leave it in the next videos. Hopefully we can finish up the rest of the problem. Answering the rest of the details in the next video. And that's it for this video. I hope you enjoy it. Please don't forget to like, and if you want to find more of my other videos, go ahead and subscribe to my channel, and also turn on the notification so that you won't miss any of my new videos either. If you have any ideas or thoughts, you can also leave your comments below, and I'll try to read and answer as soon as possible. I'll see you guys in the next video.